So I'm Rachel Andrew. I'm a web developer from the UK. And these are some of the places that you can find me on Twitter or on my own website. And I guess most usefully in the context of this talk, I'm an invited expert to the CSS Working Group. So I kind of help to make CSS, although you can't blame me for all of it. So I'm hoping that some of you have heard a little bit about this new specification, CSS Grid, a new layout method for the web, which shipped into browsers earlier this year. And if you do front-end stuff, and you haven't yet looked at Grid, then you might be thinking, well, I know about Flexbox. And I think, well, why have we even got Grid at all? Why not just use Flexbox? We've got quite good at it. We can do Grid-like things with it. So what is the difference between CSS Grid Layout and Flexbox? And defined in the specification is the biggest and sort of most obvious reason, and the kind of place that we start. And that is that Flexbox is designed for one-dimensional layout, and Grid is designed for two. So what does that mean? This is a flex layout, so it will grow and it will shrink to distribute content according to whatever screen width we've got. So you can see there, when there's fewer items in that last row, each row essentially becomes a new flex container, and space distribution happens across the row. It's not looking at what's above it and lining those last two boxes up sort of against the other two that are above. We're not staying in strict columns. So that's one-dimensional. We're either dealing with a row at a time, or we're dealing with a column at a time, depending on what our flex direction is. So if we wanted to line things up in columns, what we'd have to do is restrict the flexibility. We'd have to do something to cause those items to be a kind of known width, rather than do this space distribution thing. So if we look at Grid, and exactly the same kind of layout, this would grow and shrink according to how much space is available. The items here line up in rows and in columns, and that's basically what we mean by two-dimensional. We can do rows and columns at the same time. But in order to do this, Grid does something that all of our other layout methods don't do at all. It works from the container in. And every other method that we have of creating a grid using CSS involves sizing the individual items. So everything we've ever done before, we've had to look at the items and say, I'm going to make you a certain size so that I know that you line up with other things. So we can have a look at that. This is a simplified float example. So if you've ever built a grid using floats, so you might have used the float system that was in Bootstrap or Foundation or what have you, any kind of float-based grid system is doing this sort of thing. You float the item, you give it a width, and by doing so, you allow things to line up. And then if you want things to span, you have to add up the widths and the width of any gutter that you've got in order to make sure everything lines up. And so we end up with this. And that looks like a grid. But there isn't a grid. We've just made it look like a grid by lining stuff up. And we've done all the maths. We've done all that working out to figure out how big those things should be. And so Flexbox does work on the container. You say display flex on a parent item, and the items inside become flex items. That's true, but it doesn't give you a grid. To get a grid, you have to put widths on the items again. And so we have these row wrappers, as we do with a float-based grid, but here we're using those as a flex container, and then we use the width on the item as the flex basis, usually by giving the flex basis auto. So we're not having to do any clearing, so it's a bit better using a Flexbox-based grid. And we can use all the nice alignment stuff that's in Flexbox to make things stretch to full height and so on. That's great. But we're not really using Flexbox for what it's good at and what it's designed for, which is that space distribution. And we're still doing the maths. We're still working this stuff out. And so here we are with a grid layout, with Grid, with no maths, because we're allowing the browser, the computer, to do the maths because they happen to be really good at that stuff. So what happens on the item is a simple instruction as to how many tracks to span. So we create the tracks, and then we just say, hey, I want you to span 2 tracks. And it does. So it's a very different concept. We're defining the size of our columns when we set up the grid, and then we just tell the items how many of those column tracks we should span in sort of one of the ways that you can do that with grid layout. But all of our sizing comes here from the container. And we don't have anything else that behaves like this. Probably the closest thing that sort of does something, you say to the container, I'd like to have a certain number of columns, is multiple column layout. That's the only other thing we have in CSS that really behaves in this way. So this is key to remember. Grid frameworks, all of our old stuff, create something that looks like a grid by controlling item size. CSS Grid Layout creates a grid, and then we put stuff into it. And so CSS Grid Layout is essentially a native grid framework built right into the browser. And what I'm getting, as I've sort of been talking about grid for a long time, and people are starting to use grid now, and they are sending me their grid-based grid frameworks. And they all have like row wrappers, and are creating one-dimensional grids inside a row wrapper because they're trying to force it back to something that we had before. The reason we created all of those frameworks around older layout methods is that doing the maths is really hard, it's error-prone, you get more than 100% and everything blows up. And so we created frameworks. We don't need to do this with grid. The browser's working that stuff out for you. You create the grid, decide how many of the tracks you need to span. Every single abstraction I've seen so far has tried to force grid back into the old way of doing things. So don't do that. Make that shift in thinking. Realize that this is something very different. And so how big things are actually becomes really important once we're dealing with the container and creating tracks on the container. And a lot of the complexity, the kind of apparent complexity in grid layout, is the fact we've got a bunch of new sizing things to learn. Because we're not just dealing with this simple thing which is a certain size that we just line up. We've got to create sizing from the container and sometimes get sizing from the things inside the grid. So this example here, which is as many columns as will fit. So we want to have as many flexible columns as we can in the viewport. And that uses two methods that are designed to work on the grid container to enable these flexible sized tracks. So we have this repeat statement. So if you want to have lots of identical tracks, you can just say repeat, and then whatever you've got inside the brackets, you can repeat that. And before the comma, we say how many times to repeat. So you could say repeat 6, and you'd get 6 columns. But here I'm saying autofill. Say, hey, browser, I would like as many of these sized column tracks as you can get into this container. And then I'm using this, so I'm using this autofill to get that. And then I'm using min-max. This is where it all starts to look a little bit unusual. But min-max is fairly straightforward. What we're saying here is I'd like a minimum size of 200 pixels and a maximum of 1 FR. And that means that every track that's created will be at least 200 pixels. It's not going to get smaller than that. It doesn't matter if it's not got content in there. You can have a 200 pixel track. The maximum of 1 FR means that any leftover space gets distributed across those tracks. So we end up with as many around 200 pixel tracks as will fit into the container. And this FR unit is incredibly useful because it allows us to distribute available space. So you can specify different FR values for tracks, sharing out the available space in proportion. So here I'm saying grid template columns, 2FR, 1FR, 1FR. The available space gets divided into 4. We give 2 parts to the first track, and then 1 part, and then 1 part. And we get something like this. And if that space gets smaller and larger, it will get distributed according to the values we've put in. The really nice thing about FR units, because they're distributing available space, you can mix them with fixed width things. So here I've got a 400 pixel track, and I've got 20 pixel gutters. So the first thing the browser does is it says, oh, well, we need to take away 400 pixels, and we need to take away 2 lots of 20 pixels, because that's this sort of fixed width, absolute sized things. The rest of the space, I've got 2 1FR tracks, well, they each get half of that available space. And so we get this. The fixed track will stay a fixed size if the space gets smaller. The 1FR tracks will grow and shrink. So in our 12-column grid example, the FR unit means we don't need to worry about the fixed pixel width used for gutter tracks, and we don't need to set that in percentages if we don't want to. We don't have to go around calculating percentages, because what the browser will do is remove all the space needed for those gutter tracks and then split the rest of the space between our FR tracks. And so we get this sort of thing. The column tracks there are detailed on the container. And the thing with the FR unit, when people are coming to grid layout, quite often they will try and calculate all of their percentages, which isn't surprising. We're used to calculating percentages. That's how we do things. Most of the time, you can replace your percentages with the FR unit, and that will work very, very nicely. About the only reason I'm using percentages is if I have got layouts that include mixed up things. So I've got some multi-call, I've got some grid, I've got some flexbox, and I want them all to have an accurate gutter size where everything will line up. I might use percentages then because I can use that in all of my layout methods. But if you're not doing that sort of thing, most of the time the FR unit is what you want to use because it will allow the browser to sort out that sizing for you. And I want to go back to this min-max function because it's useful all over the place, allowing us to set this minimum and maximum size for tracks. So in this case, I don't want my tracks to get too small. I don't want them to collapse smaller than 200 pixels. That's why I'm using min-max. But we can also use it to make very precise-looking layouts that also cope with the fact that sometimes more stuff gets into the layout than we expected when we designed it. So we can have these very precise-looking things which, when a load of content gets chucked in, they expand and cope. So this is what I mean. Here's an example. I've got a panel here that's similar to that sort of panel of photos you get on Facebook. They do that nice little panel. And I've also put some text in there. So I've got different size photos arranged to make a nice, neat grid and a bit of text. And this is how I ideally want it to look. And so this is the grid definition for the panel. I've got column tracks there. And I've also used the grid auto rows property. So any rows that are created in the implicit grid will be at least 200 pixels tall and a maximum of auto. And it's that maximum of auto that's really important. So I've sort of highlighted the row lines here. So you can see they're all 200 pixels tall. So I'm able to put my images and things in there, my text, and that bit of text is spanning 2 tracks. It's not taller than 400 pixels, so it all fits in really beautifully. And that's great. And then I hand that over to whoever's editing content, and it gets into the CMS, and then it ends up looking like this, which is fine, because that track has just expanded to take the content, because we've got a maximum of auto, which is looking at the content size and is just growing and allowing the content to sort of stretch down. And that growth happens right across the row, which if you see, I put the lines in there, you can see now how that track, that second track, has grown taller, and it's done that right across the row, which is an important consideration. If you're using images, I'm using object fit here so that my image will just grow and stretch in the next track. If that happens, it's important to consider that because things are going to expand the entire row or the entire column, if you're allowing the content to affect sizing, that needs to work down the column or across the row. I can actually nest a grid and use the same technique to add a caption. So I've made the figure a 2-row track grid. I'm causing the image to span 2 rows, and then I'm placing the caption in row 2, so it overlays the image. This is something nice we can do with grid layout. We can put multiple things into the same cell and layer them up. And they'll just use Z-index in order to see which one should be on top. So I can do that, and I'm giving it a minimum height of 100 pixels, so we always get a certain height, and again, a max of auto, which means that sometimes we might have some captions that wrap onto 2 lines, and it will just expand to take that text. But what I do want to point out about this is something that we'll come back to a little bit later in this talk. The captions at the bottom there don't line up, and that's because that nested grid has absolutely no relationship at all to the outer grid. It's a new grid. You can make a grid item a grid container, just like you can make a flex item a flex container. But the direct children have no relationship to the things outside, and so we can't tell those 2 captions to line up with each other. They're in different grids. And I'll return to that thought in a little bit. But first, I want to carry on talking about how big things are. So we define a grid on the parent, and then we put content into the cells created. But content can obviously define the size of tracks. We've seen that with min-max. We're saying with a max of auto, things can get bigger. So you have to remember that that's going to happen right across the track. We've also got some new sizing keywords, which can be used with grid layout to help us with this content-defined sizing. And these are those keywords. We've got min content, max content, and fit content. So min content. This will use all of the wrapping opportunities available to make it as small as it can possibly be. So we use this keyword min content as a track size in grid, and we'll get this. So you can see that the only cell that's got a load of text in is that first one, and what's happened is it's wrapped as small as it can get. So it's just that last word that's making the size of that track. So the biggest thing in the column, so if there was something bigger in the second cell down, obviously that would define the size of the track. So it will wrap everything as much as it can, and that's min content as it works in grid layout. So max content does the opposite. It tries to get as big as possible. It doesn't take advantage of any of those wrapping opportunities. And so here the line will spread out, and it will keep spreading out, and if you've got a great big long sentence, it will carry on, it will cause overflows. So that's max content. It's getting as big as it possibly can get. But then we also have something called fit content. And fit content, we pass in a value, and the track will act like max content, so it will keep on spreading out until it gets to the size you put in that value, and then it will stop, which is really, really useful, because we get things like this. So we can have a column, that first column, if that was max content, that would keep on growing and spread out and probably cause a scroll bar somewhere. So we don't want that. So we use fit content. So we say, well, get as big as you can, but then if you get to the size I've specified, I'd like you to stop. The next track along also has fit content, but it's only got those numbers in it, so it never gets bigger than the number. So that's really useful. It's a good way to sort of play around with the sizing of content, allowing things to have a bit more space, but not actually overflow all over the place. There's lots of little uses for these content keywords, definitely something to play around with, and definitely something to remember that you have and that you can use if you're using grid layout. I forget about them all the time and sort of think, how am I going to get this track to be the right size? And quite often, it's those content keywords are really useful. And then, well, we have to talk about old browsers. Because if I don't talk about old browsers up here, you will come and talk about old browsers to me. So we might as well just sort this out right here and now. So, old browsers, they've always been with us. But we've got a bit better with CSS at kind of building stuff into the specifications to sort out the old browser problem, like right from within CSS, rather than us having to do any sort of nasty things to deal with that. So in the grid spec and also in the Flexbox spec, it explains what happens if two layout methods collide. So if you've used an old layout method for older browsers, and then you make those things into grid items, what happens? Well, usually it works pretty much as you'd want it to. So if you float something, so if you floated an item, and then that item becomes a grid item or a flex item, the float properties just get thrown away. You don't have to do anything about them, you don't have to fork your code, you can just ignore that they ever happened. And clear is the same. So the item can be floated, and then as long as you do the grid stuff afterwards, it's not going to be floated anymore, and nothing will happen. So then we have inline block. That's quite useful for doing these kind of multiple column type layouts. If an inline block item becomes a flex or a grid item, it stops being inline blocky, which means you don't get that weird thing where it respects white space and you have to bunch up all your text and so on. Well, that won't happen anymore. It'll go away. So you can have something that's set to inline block, makes a grid item, and any sort of inline-y properties will stop happening once it becomes a grid item. It gets blockified and it behaves like a grid item. Display table properties, so doing things like table cell. I think display table cell is the sort of the killer tool to use if you need to support very old IEs. I do, my product has to support IE9. Display table cell is really useful for that. The thing about if you set something to display table cell, what you get, what the browser does is it creates anonymous boxes. So it creates the table row and the table wrappers around. Now, if it becomes a grid item, you wouldn't want those things floating around, becoming some sort of weird anonymous grid items. So that doesn't happen. It gets blockified, it stops being a table cell before that stage happens, so you don't get any weird anonymous boxes. You can happily use display table cell as a fallback for grid. And on that note, vertical align, which works with inline block and table cell, it's how we kind of do alignment, and it's often used for things like proper vertical alignment in older browsers. Again, that gets thrown away if the thing becomes a grid item, so that's pretty cool. And don't forget multiple column layout. Not used that often, but can actually be quite a good fallback for grid because it works on the parent. And for things like layouts of cards or whatever, if you don't mind that they're going to run column-wise rather than row-wise, might be a fallback. So, of course, you can use multiple column layout. If it then becomes a grid, those column properties just get thrown away. And, of course, flex layout. You can use Flexbox as a fallback for grid if you want to. It's going to cover a few more browsers. And you also get to use the same alignment properties, so that might be quite useful too. And if something is a flex item, then becomes a grid item, the flex properties that would be applied to the child, again, they just get thrown away. So that's pretty neat. What you do need to remember is you need to be using the cascade properly. Write your code for your old browsers and then code for new browsers, and this, a lot of the time, will just work. The way that browsers deal with this stuff is the ones that understand the first instruction will say float, they'll do the float thing. They'll see the grid stuff, they'll be like, don't know what that is, and ignore it. The browsers that see the float thing and then see the grid thing will be like, I know about grid, do the grid thing, and the way that CSS has specified this, it ignores the float thing. And so this will just work. But there is a problem. There are some places where your grid supporting browsers are going to use some of the non-grid code and everything's going to get into a mess. This is an example. If we say float left and width 33% or whatever to make floated columns, well, when the item becomes a grid item, it's going to end up 33% of the grid track, which is going to be a third as skinny as we would like it to be. That's not what we want. But it's okay, because CSS has fixed that problem for us too, with feature queries. Feature queries are going to be your new best friend. They've got really good support, and it doesn't matter that, say, IE11 doesn't support them, because the way we use them is we do our old stuff, and then we do the new stuff inside the feature query and just overwrite all of that old stuff, so it doesn't matter. So this is how we do that. So I'm going to test for the browser and find out if it supports display grid. No, this is just if the browser claims that it does. We don't test whether it actually has like good support or anything. Just saying, well, you know, hey browser, do you support display grid? It says I do. And so we set the width back to auto. And that's it. And our columns now won't be shrinking down to a third of the size of the column track. But all of this is all pretty straightforward to do. And in reality, in production, most of my feature queries are just full of a set of resets. I'm just putting my sizes back to auto, maybe removing a few margins. This is all pretty simple, as long as you understand CSS. You need to know how to use the cascade. That's how we can create graceful fallbacks with minimal code. You do need to understand CSS. We've been working with abstractions for a long time. I think a lot of us have. We've been using frameworks and stuff because we were sick of doing the maths. It is worth spending a bit of time going back to basics and making sure you actually understand what the browser is doing with this stuff. It will pay massive dividends. It's really important. And really, the fundamentals of CSS haven't changed a lot. We've got all this shiny new stuff, but that's just learning some properties. And you know what? We don't all learn all the properties. I know quite a lot about layout, but every time I need to do like any animation or whatever, I'm like right back having to look up. I'm on MDN having a search because I can't remember what to use. So you don't need to become a walking book of properties. You need to understand just how CSS works, what this beast is, because it'll make all of the rest a lot easier. It won't be a weird black box. So some of the things that people have been asking me about and some of the things people want to do and we can't quite do yet, I wanted to talk a bit about that. And we saw an example earlier where things just didn't line up across the row because they were in a nested grid. And I said, well, a nested grid can't participate in the overall grid layout. Now, we did have something in the spec which has been removed from the level 1 spec because it just turned out to be really hard. And we're going to hopefully bring it back again, and that's the ability to have a subgrid. So here's the example of why we might want subgrid. This is the sort of layout you get from a designer who believes that content comes out of the CMS in perfect line lengths. And so everything is lining up beautifully, isn't it? And you go, oh yeah, I can do that with grid. Really simple. Say display grid, and I have got 3 column tracks there, and that's all really nice. But then the real world of real data happens, and we get this. And the designer says, no, that's not what I wanted. I think, yeah, I really want those lined up across the boxes, and about the best we can really do at the moment is we can make the internals a nested grid or a flex container and basically push the footer down to the bottom. And we do that. And this is a bit better, but it's still not what we really wanted. What we wanted was if the title was longer, it would line up right across the row, and if the footer was taller, that would line up across the row, and it would all be nice and neat. And that's what subgrid would give us. So if we use the spec that was pushed out of level 1, we'd need to know that our subgrid has got 4 rows in it. It's got 4 column tracks, and so we'd need to make sure that we defined that amount of space for it to fit in. And so we'd end up with something like this. We'd say the grid row auto span 4, so that it would stretch over, and then we'd say display subgrid. So basically telling that item to use the parent grid, the rows defined on the parent, rather than defining its own rows. And that would give us this sort of idea that I've mocked up here. The elements inside the card actually participating in the grid layout of the parent, so that the sizing right across the track would line up. It's a little bit simplified. We probably also need to deal with the gap and so on. But this is all completely theoretical. There were no implementations of this. It was pushed into level 2 because I actually think we need to talk about this further, and we need to talk about how we deal with content where we don't know how many tracks we want in our subgrid, for example. I'd like more people to bring use cases to the CSS Working Group so we can come up with a subgrid solution that really, really works with the type of content that you're all creating. This is a bunch of stuff about subgrid. You can comment directly on the issue at the CSS Working Group GitHub. You can comment on any issue. You can raise your own. Please, please do. If you are hitting against use cases that need subgrid, I would like to see them. The working group would like to see them. Please let me know about them. I'll go and post them over at GitHub so that we can actually design something. When it goes into level 2, we can design something that really actually works. That would be fantastic. And something else that people would like to be able to do. Most people seem to look at grid layout and go, this will do masonry, and no, it won't. So we can make things look like masonry if we place each item. So this sort of gallery, you could imagine this to be a bit like a masonry layout, the sort of Pinterest layout. And we can kind of get there a little bit because we've got this auto placement thing in grid. So we can auto-place things on the grid, take a bunch of things, throw them at a grid, grid will place them one into each cell, and we can even make some of the items span over different tracks. So we can end up with something like this, because grid will stay here in source order, and it won't sort of take things out of source order to fill up the gaps. But we can make it do so if we want. If we set grid autoflow to dense, grid will actually pick up items and it will take them out of source order to put them into the gaps, which of course can cause all sorts of problems in terms of accessibility. Be really careful if you try and do this. But it's still a strict grid with rows and columns. So if we put the lines across, you can see this is actually just a strict grid. Just some things are spanning tracks on the grid. What people tend to want with masonry or Pinterest type layouts looks a bit like this. Stuff stays in document order, it goes across the row, but then when there's kind of a gap, it sort of pushes the thing up into the gap. It's kind of like a sort of weird two-dimensional version of Flexbox. It's not quite a grid. And currently, the closest you can get to masonry is with multiple column layout. But I know people would like to solve this problem in the browser rather than having to use some sort of JavaScript to do that. Again, I've written about it. We've got an enormous thread on GitHub for the CSS Working Group where people are talking about this and saying how much they want it. Do come and post that stuff. It's important. It shows there is interest. It shows there's interest to browser implementers. It shows there's interest at the working group for us actually to work on this stuff and get something into the spec, into the browsers for you. And they're just a couple of examples. As you're playing with this stuff, you are going to find things where it doesn't do what you thought or it doesn't do what you need, and that's okay. And this is all really new. And we built this stuff, people at the CSS Working Group and the browser vendors built something which is groundbreaking, but it doesn't mean it's going to solve all the problems. So as you're finding stuff, make sure you come and talk about it, because I've only been using this in production since March, just like anyone else, because although I was playing with it for ages, it's very different when you actually get it into a real product. So, we're all still learning. And so if you manage to solve problems, write about it. If it's failing you, write about it. solve the problems, and share what you found out, because that will actually help make the web better for everyone in a very, very real sense. You know, we're listening to the community so that we can produce the CSS that you want. If this has been very new to you, I have tons of stuff, including a video tutorial on Grid by Example. You can go there and work through some of that and play around with Grid. I wrote the guides for MDN, so that's loads of words about Grid if you like reading words rather than watching videos. And I'm also collecting any interoperability issues. Grid's pretty good cross-browser, and it's actually, the updated version is coming out in Edge next week as well. So we'll have really, across all the modern browsers, we'll have Grid support. And it's pretty good in terms of, there's not a huge amount of bugs, but there's obviously a few. Those I'm finding, I'm collecting on my Grid bugs repository. If you find any, please go and raise an issue there, and we can figure out what it is and get it logged in the right places so it gets fixed. And if you enjoyed all this stuff, my new book came out this week. So, thank you. And that's really all about layout and how Grid and the new stuff fits into the overall picture of layout, and I really hope it will be helpful for people. All my slides and things are online, and I'll just take some questions. So thank you very much for listening.